Okay, word problems involving exponentials. We talked about exponential growth and decay. We have two formulas for there. Growth model. Again, exponential growth, that base value is always greater than 1. So if I take 1 plus a rate, which a rate is always positive, that's going to give me a value that's greater than 1. So that is why it's always 1 plus r. And then again, we got that a value. And the a value is going to represent our initial amount. R, like I had said, is the rate, which is typically given to you in percent, but you do not want to write it as a percent. We're always going to write that percent as a decimal, and then T is our time. Okay, decay model, A, R, and T represent the same thing, except again, decay model, you're going to have 1 minus the rate, which will give you that value that it will be between 0 and 1. Now, anytime we talk about some type of account where it's compounding interest, we're going to use one of these two formulas. Okay, so the first one is when we're given a specific frequency and a specific number of times it's going to be compounded. Okay, so P is going to represent your principal. R, same thing as your rate that you're earning. N is our frequency, and T is our time. So that first formula there, that's given a specific frequency. If you're given this bottom one, the A is equal to PE to the RT, I call it the PERT formula. This is what you will use this when you are doing continuously compounding. Okay, so that's for a specific case. Now, I should mention frequency. That's just talking about how often it happens. So like if I were to say annually, that's 1 time. If I was to say monthly, that's 12 times a year. If I was to say weekly, 52 weeks in a year. Okay, that's the frequency that we're talking about. So if we look, you deposit $500 in an account. Okay, right there, there's our principal. We got a p-value of $500. And the fact that we're talking about an account, that tells us we're going to be using that compound interest formula. And it's just a matter of what one we're going to use in this case. Okay, so we have a principal of $500. Pay 3% annual interest. So we got 3% again there. That's our rate. So we have an R value of 3%, which we're going to write as 0.03, so it's not a percent. Now, we got also find balance after 2 years, which is our time. Okay, if the compounded with the given frequency. So when I say annually, that is a frequency of 1. If I were to say quarterly, that is 4 times a year. If I was to say daily, 365 days in a year, so 365. So going ahead, plugging these into our formula, because our formula, if we look again, A is equal to that P times 1 plus R over N to the NT. So just plugging in what we know. The amount A that we're looking to get, okay, our principal was 500 times 1 plus our rate was 0.03. Annually in this case, over 1 to the NT. So N, which is 1, times T, which is 2 in this case. Okay, let's go ahead and let's just set these all up. So 500. And the only thing that's changing between all three of them is that N value. Now that N value is in 2 different places, so make sure you are doing it both. Okay, from there, it's just a matter of plugging it into your calculator, which I'll allow you to do. Biggest thing with these word problems is the setup and making sure you're plugging things into the proper place. Radioactive decay. Okay, decay right there tells you that should be a decay model. Amount Y in grams of a sample of iodine 131 after T days is given by Y equals 50 times 0.92 to the t. So they give us the equation. So if you remember decay, A is the initial amount. So in part A here, it says identify the initial amount of the substance. 50 is in place of A. So therefore, we have 50, and it's talking the amount in grams of, so we have 50 grams. Now, what percent of the substance decays each day? So if you remember, we know the base value is 0.92, and this question is basically asking for that R value. So that 0.92 is in place of the 1 minus R. So if I just go ahead and I can make an equation, and you solve for that, you're going to get 0.08. So 8% of the substance each day is decaying. Okay, looking at the next one. An adult takes 400 milligrams of ibuprofen each hour. H, the amount of ibuprofen in the person's system decreases by about 29%. If you just think about it, you take some ibuprofen or Tylenol or whatever, that pill is decaying within your body, so we have a decay model. So y is equal to A times 1 minus R to the T. If we fill in what we know, this 400, that's the initial amount that we have, so that's our A value. We got a decay rate of 29%, which I'll write as 0.29. Okay, and to the T. Now, in this case, writing a model, we're writing an equation that will represent any situation. Like I can say, okay, after 3 hours, how much ibuprofen is in the man's system. This is where we could take that 3, plug it into T. Now, we should simplify that 1 minus 0.29 and replace, like this H, that's our time. So we should be putting H in place of T, and we should also be replacing I in place of Y. So, final model, I is equal to 400 times that 0.71 to the H. That is our model for the situation. And again, I could say how much ibuprofen is in the man's system after 3 hours. Plug 3 into H, and that will give me the amount. Continuously compounding. Again, being compounded, meaning we're talking about one of our compound interest formulas. And since it's continuous, that's the indicator that we're going to use our Y is equal to our PERT. Again, P is our principal, which we have 975. So we're going to plug that in. E is a special number, just like pi. Okay, it's used so often in math and science that they have a special character for it. In this case, E. Okay, we have a rate of 5.5%, which is 0.055 in terms of a decimal, and it's asking for after 6 years. Okay, so going and plugging this in, I will show you this one just because of the E. 975 times, so if you look at it, 975, and we got that E. If you look on the left side towards the bottom, you see that in the blue, you got E to the X. That is the button we're going to use. Second ln then. Okay, and then we had 0.055 times 6. So looking for the amount after 6 years. Hit enter. 1,356.19. And again, since we're talking about money, we're always going to round to the hundredths place. Okay, that is word problems for exponential growth and decay, and along with compound interest. One thing to remember, always just make sure, decipher the information, make sure you're using the proper formula, and then plug in the information into the proper spot. And then it's a matter of just plugging it into your calculator.